Okay, let's continue. So I'm very sorry, Monday is not my day because I have forgotten about to tell very important moments about strings. So please let's get back to calculate words class. And here, after we have calculated this count by undocumented split feature, now let's count these words by much more correct way. And here I will show the important moment about string equality. So here, count by given word. So let's, after counting by split, let's make one more comment. And here, let's split this text by spaces. So we will have this. So let's have here separate words. So like this one. And once you are done, please give me a sign. So the main idea is we can split this text on separate words and just simply check if this word is equal to one that we one that we want to check. In previously we have compared some integer variable to some value. So like this, some int e is equal to 5, and then if e is equal to 5, we are doing something. So we can perform the same operation with strings, but here's the very important moment. So now let's let's write a simple for loop. Let's call it words. So let's write a simple for loop, and here we are working on these words with s array and getting each word separately. But before, let's create some counter variable. So please add this counter with initial value and this for loop. So how do we check strings on equality? So if the basic the first approach that comes into heads will be something like this. If word is the same as then we are increasing our counter, and later we are printing this counter. So please rewrite this condition and this print line, and let's look on the results. So result seems a little bit confusing, isn't it? So if it looks confusing, let's fix this equality part. So when we are working with primitives like int, boolean, long, we can compare them with two equality signs. But the problem is that string is not primitive, it's an object. And for the objects, we are using not two equality signs, but we are using function equals. So we are calling function equals and putting here in brackets the argument what we are comparing. So please rewrite this equals and put this word inside these brackets. And let's then run once more. So let's apply additional comment here. Never use two equality signs here. So, however, these two equality signs will compile. Uh, it will not work when we are comparing objects by its contents. So when we are comparing strings on equality, we always use this special equals function. So here we have string literal, so we do not have this inside object like here. So we write string and we already can use all the functions here. So we are calling function equals and this will result as a boolean variable. So you can please rewrite this part like this. Comment with everything in uppercase because that's really important. And that's how we can compare two strings. So have you reworked this part of code? Okay, is it now clear how we can compare strings? So if we want to check on equality, always use equals function and never use these two equality signs. So that was the important moment. And so now this code looks quite simple because we're taking each next word after a split and comparing these two words that we need to count. If these words are equal, okay, we are increasing counter, and after loop is finished, we're just printing this counter. So please hold this important moment in a head, because uh, this is a very often mistake by beginners when trying to compare strings by two equality signs, and it's hard to debug and understand where is the problem. So please note this important moment about this function equality when we need to compare strings. Okay, now let's get back to collections to lists. And here inside this class, let's create some cookbook of how do we use lists. So the first operation is adding elements to list. So how do we do it? So we are writing variable name and calling function add. So add let's add 5. Then let's add 3. Let's add some more elements. So does it look that we already done it before? So we have seen something similar before. So we have done something really similar with our awesome list. So that's why I gave this exercise about awesome list. So Java has its own implementation of list, and it is much more sophisticated and complicated than we have, but the main functions are called the same. So add, if we need to add some elements inside list, okay, we can use the same function. So please rewrite this part. So this is a first part of our cookbook. So that's how we are adding elements to a list. Okay, so that's how we are adding just simple hard-coded values. Now let's create some integer array and just very small array with values, I don't know, 1, 2, 3. And let's move all these values inside our list. So we're doing in the same manner. So list add new element. So here we can call this function not only with some predefinite value, but with some variable. So here we got variable from array and put in here inside the list. So please rewrite also this small example. Maybe let's put even more comment. And now it is a great time to know how to get elements from array. Of course, adding elements to array it's a great thing, but after adding them, it would be great to take them out from a list. So how can we do it? We can do it. So we cannot get the internal state of this list. But we can do it in another way. We can use for loop. And here, I just to understand that list length or size, I am using this function size. We have already done this for awesome list, and here for Java list it has the same name. So this will say us the real size of collection. So we are iterating by one until we reach this list size. And how do we get elements from a list? Any guess about it? Yes, exactly. So let's get some element from a list and put it inside another variable. List dot get, and here inside the get we are passing this our iterator, this e. And let's just to test how it works, let's print this element and extra space. After that, let's print just empty line. And one more extra comment. So getting values from list. In old style. Yes, so please copy this code. And when it is done, let's try to run. So did you got the same results as me? So here we can test that we have really added these elements, and then we have taken these elements from array one by one and in a loop added inside our list. So and here just one by one taking elements out of a list and getting the expected result. So here I have put a remark here about old style. So here even idea shows you that for loop replaceable with enhanced for. So we have learned three ways of writing loops: while, do while, and for. So actually there are well even more types, but here we will learn the fourth way. It is much more short than this traditional for loop. So how do we write it? So here I'll put the same comment but new style. So syntax is next. So for absolutely the same, and here we write int element call and list. And now let's just print this element and after for loop print extra line. So please rewrite this example and please be very careful with this new syntax. So let's run and check that we have absolutely same results. Okay, half more minute, and then we will talk about this syntax, how this works. Okay, so about the syntax. So here we have this sign call, and from a right part we have collection from which we are getting results. So so here before we have used this collection to get size of collection and to when we are calling this get. Here we have just this collection named, and here before we have a declaration of next element from collection. So here, so what actually Java compiler does for us? So here we in old style we have iterator variable and calling a get. So actually we need this e only just to limit how much this loop iterations do we have to do. So from 0 till list size. And what we're doing next, we're getting element by the syntax. So that's a little bit boilerplate. So we have this e needed just to limit just to take every next element from array, from collection actually. But here Java compiler does it in our place. So it removes this all connected to E and checking this list size and putting a next element of collection already here inside declaration. So this in 2 lines of code becomes this. So here inside element, here it is not an index. Here it is next collection from element. So let's run in a debug. So here we have list and here are the values 5, 3, 2, 7 and so on. Here element. I'm writing debug and here element is equal to 5. So that's the first element in collection. Going till the next iteration, here element now is 3. Now 2. So that's just so here inside variable element, here will be stored the next element from a list. So we do not have to deal with iterators. We are already getting the values. So actually we are doing the same like here, but just in a compact way. So here we do not have to deal with checking the list size and all the time dealing with this iterator value. So this is a short way how to work with each list element. So if we do not need to create calculations on this E somehow, so when we need iterator just to pass all the collection and get some elements, we can write this in a short way. Is this clear about this short syntax? And do you like this more than this old style with a lot of boilerplate code? So this is not universal, but if we do not, if we need E only just to get next element from a collection, we can use this code. But in case if we need to, I don't know, take each second variable value from list, okay, then we will need this old style way. So please pay attention what idea says to you. So here idea says me for loop can be replaced with enhanced for. So I can even press here Alt Enter and here's an option replace with enhanced for. So you see absolutely the same like we have here written next. So if idea tells you that you can replace this with enhanced for, so that means you're using this iterator E variable just for getting each next element from array. And in that case, you can use this short syntax. Okay, so here it is. We just added some elements inside our list, and we got elements from a list in 2 ways, old style and new style. And here it is when we use size of a list, when we are dealing with old style, iterating, we can use this size to understand how much elements inside collection do we have. Okay, now let's perform a small practical assignment. So, do you remember when we talked about arrays? Here we had array operations, and we have calculated sum of elements inside array. Okay, let's do the same. So your next small practical assignment. So we have values inside the list. So I want you to sum all the elements inside the list and print it. Uh, so absolutely the same like we have done before for array. But for now with with a list. So this assignment is clear. What do we need to achieve? Okay, let's go. So I give you 5 minutes on that. So till 2053. Good luck. Well, okay, I see that you reached success here. So theoretically, we declare int sum is equal to 0 from a start, and then here inside enhanced for loop, we are just performing sum with each next element. And here we are just printing sum. Well, looks like this is correct. Sum of list elements. Okay, I hope you got the same result. So, let's get back a little bit to theory. So list is an ordered collection, and list may contain duplicate elements. So as we have seen before, we have here elements are stored in a way that we have added them. So 5, 3, 2, and so on. So how do we enter them here? In that way they are stored. And you see that we have here duplicate elements. So it is how lists works. And okay, here we have some a little bit more. So positional access. So we can manipulate with this list when we know indexes of elements. And okay, here are two implementations, but we will use just array list. So if we need to, so we have written in our awesome list function remove. Here we have also some alternative for this remove. So actually the same remove. For example, I want to remove this 1. So let's count the index. 0, 1, 2, 3, 4, 5. Okay, remove 5. Remove element at index 5. Okay, and let's print this list in in uh, in comfort way. So when we're dealing with Java built-in list, we can use we can just use this list variable. So we could not use this approach with our awesome list or with arrays, but we can use this with Java built-in list. So when I run it, so you see that this element at index 5 now is missing, and it is now printed in this way. So here we have, so when we are printing Java list, it is taken in such square brackets and commas between elements. So this looks quite readable. So please rewrite these lines of code. So we can remove element from a list by index. So that's looks like exactly what we have done before in our awesome list. But here is the difference. We can very simply print this list. So, okay, it is now more or less clear with Java list. Uh, so that's how we declare list, and that's how we use it. So I have seen that you liked example with cats. So let's create also let's declare some array list with cats. So how do we do it? Okay, let's create a new array list that and here in this triangle brackets I'm writing this another type, not integer but cat. Let's call this collection cats new array list. So and now let's add some cats inside. So I am writing add, and here I need to add a new cat. So new cat and uh, well, okay. So let's create a cat called Prince, and let's give him name. Okay, let's just back to class zoo basics. So here we had here two cats, Prince and Murinch. So let's just copy paste some lines of code. So declaration for first cat and for second cat. So let's just copy paste a little bit, and here cats add Prince and add second cat Murinch. So please rewrite this example. So this initialization with values you can copy paste from class zoo. Okay, so that's how we added some cats in a list. Okay, now let's try to perform some actions with these cats. So let's write first. So let's work with them in a loop. So let's write this enhanced for loop for cats. So here, so that's how this enhanced for syntax will work for cats. So here it is collection name cats, and here this variable cat. So this is just next cat from our collection. So here they are named Prince and Munich. That's okay. But here inside the loop they are called simply cats. That's just how we have named this our variable. So here in variable cat we will have one of these cats. And what can we do with this cat? Okay, cat. Let's just take a next cat from collection and ask him to perform some action. And more comment here. Perform call function. So please rewrite this example. So here it is too much cats on one line, on line 72, but that's how it works. So imagine a situation. We have some uh, box that when somebody created some cats, give them a name and age, put them into a box, and then we are coming to box and taking every next cat from a box. So we don't know how they are called. We call each of them cat. We are getting this cat and ask him to perform some action. Now let's run this code and looks. So the first cat eats my hand and second one sleeps. So this output may be different for you because this perform action is based on randomness, just like with real cats. So it is now more or less clear with how do lists work and how to manipulate with them. If you have red cat, so the first problem may be if you haven't imported this. So put here pointer. Maybe it's not imported. So IDEA may tell you if you need to import it, just like here with Alt Enter, or if it's not imported automatically, then please write import and where your actual class cat is located. Okay. So again, a question, is it now understood with basic list usage? And can we go to the next collections? Okay, why so many cats in one line? Okay, let's back to our example with integers. So here it is syntax, enhanced for loop syntax. So here's on the right part we have collection name. On the left part we have declaration for next collection element. So this is let's say some temporary variable, just like we have used this int e before. So we have declared this for loop, and we are using this inside loop. So each next loop iteration, this e will get a new value. Exactly the same. So this variable element will get next value from a list on the next loop iteration. And so this is the syntax for variable type. So we are holding integers inside our list. So here it is int. Here it is, so we can call this variable. How do we want? We can call it like this, not a problem. But what we should definitely write correctly here, here from a right part, we need to write collection name from which we are getting elements. And now getting back here. So on the right part we have cats. So this is how our collection is called. So this list is called cats. What do we have inside this? What type of variables we are storing inside this collection? We are storing variables of type cat. So this is how our class is called, cat, from a big, from an uppercase. So the type will be cat uh, from uppercase. Here it is our collection. And now this cat from a small, it is let's say it's our loop variable. So that's how we name variable that will be used inside each loop iteration. So we do see here that this variable will hold the next cat from collection. So we see that on the first loop iteration there will be prince. So because we have added him first inside collection. And on the next loop iteration we have Emurinch because we have added him second. So we can remove call this variable how do we want. Just we need to follow the rules of variable naming convention. But just for readability, it is often called just like a class name, just but from lowercase. So here we have too much cats on a square meter, but that's how it's usually written on a production code. So I hope I have answered the question. So if everything is clear with lists, let's move to a new another collection type, and let's create a new class called try set with main function inside. Okay, now let's look on a theory. So set, it's another type of collection, and the main characteristics of this is it is a collection that cannot contain duplicate elements. So earlier we had a list that in which we can add duplicate elements, so we can just ask add, for example, 5, and then add 5 once again, and the list will hold all these collections untouched. So how do we add collections inside a list? So there will be stored. But instead of this, set will not contain duplicate elements. So when we will try to add some duplicate element inside set, so it will not be added. And the next important thing that by default, set will not hold the order of elements added. So we will have here two types of set. One is hash set and second is linked hash set. So let's start from the first one. So again, we will have integer in this triangle brackets. So again, you will have to import this class. So once declared, let's add some new elements inside. Okay, let's add. So the function for adding is called the same, add. Hash set add 3. Okay, please rewrite this example. And after adding, let's print what do we have inside this collection. Okay, let's try. So my result may a little bit differ to you. And look, what do we see here? So the order, as we have added elements inside, is not saved. So here we have different order. This is the first part. And the second, problem that we do not have second 5. So we have added value 5 two times, but here we have only one. So here we have these two unique characteristics. So hash set by default does not save order as we have added elements. So uh, so this order will not be preserved. And the second unique characteristic is that hash set doesn't will not hold duplicated elements. So once you have added 5, you will cannot add 5 once more. And okay, well, now let's try to do something with something more with this hash set. Let's try to iterate over elements that we can have here. So let's write so this enhanced for loop. Now for start, let's just simply print this. So here's it is example how to iterate over a hash set. So please rewrite this example. So most probably you will get the same result as we have printed this hash set before. So please rewrite this example and let me know when you are done. Uh, no, hash about an order. So what happens here inside this hash set? We are talking in a main bootcamp. So there's some mathematics beneath. So this order is not nor ascending nor descending. It's you can just imagine that this is random. So you can put here some more elements, and you will see that order is not nor ascending nor descending. So for hash set, just remember that order is just is something, and it is not absolutely guaranteed. So, well, you see that uh, we are iterating over hash set in very similar way, like here with loop with list. But here's an important note that we just because hash set does not have indexes, because order is not anyhow guaranteed. So hash set doesn't hold indexes. So we cannot get value from hash set by index. So hash set doesn't have indexes inside. So here are the only functions that we can call for hash set. So here it is add, size, clear. Okay, that's just clears all the value. Okay, clone, that's not necessary. Contains. So that's a good function that says us, does hash set contains some object or no? Is empty is okay, that's connected to size, remove to array. So These useful functions for hash set is following. So first one is contains. So let's check, does this hash set contains, for example, 12? So contains 12. And let's one more try with okay, 3 for example. Contains 3. So here are two examples. Does hash set contains some element? So actually, on the first try with 12, we will get false because this hash set doesn't contain this element. But with 3, this works. So this function will say us is element contain does our hash set contains such element, and here's the result. It's a logical fact, so it's Boolean variable. Uh, so okay, and this remove works in a little bit different manner than with lists. So we can also remove variable from a list by its value, but we can remove from a list by index and by value. For a hash set, we do not have indexes, so we can remove only by value. So remove element. So let's remove, for example, 9. And after that, let's print our hash set once more. Okay, so please rewrite these two examples with contains and with remove. So we see here after removing element from a hash set, it's really removed. And well, we got 4 minutes just left. So now let me show you the second option, linked hash set. Linked hash set. So again, here we use integer. So in case we need to prevent duplicates in our collection, but we need to preserve adding order, we are using linked hash set. So link hash set add. Let's do the same. So I just copy paste these addings, and here I just change the collection name. So I am adding the same elements to linked hash set, and after let's print this linked hash set. And here I will write a very important comment. So when you rewrite this example, let's run it and look on the results. Okay, so let's run this. And what do we have here? So just comparing to the first printing of usual hash set. So when using usual hash set, order is not preserved. When using linked hash set, order is preserved. So here, just as we have added elements inside linked hash set, so they are now here. Important moment here. So adding duplicate element still would not work. Otherwise, there's no meaning in linked hash set if it is works just like list. So the main feature of using sets, it's guaranteed guaranteedly no duplicates. So linked hash set is really hardly used because it requires additional memory to store this uh, order of adding elements. So it is really hardly used. But hash set is much more used. And here's the important moment. When we have uh, we have added 5 on the first time and on fourth time. So position where it is stored here, it's the first because we have added this on the first position, and when we have tried to add 5 once again, so this instruction was ignored because it contains duplicate value. So once element is added into linked hash set, it will be preserved exactly in this position. So when we are trying to add this one more time, so this position will not be here. So only the first time we have added this. So do you have questions on using sets? Okay. So current today I will not give you a homework because for homework we need to take the next collection type. But today we do not have time for this. So that's a rare case when you do not have a homework. So, uh, so okay, so please just check and remember what is the difference between list and set. And okay, so till next lesson, please perform. So if you haven't written me email with your name, surname, and Discord nickname. So please do it till next lesson, and please think about these ideas about our final works. Okay, so now I wish you a nice evening and goodbye.